Hello, I hope everyone is doing fine. Today I will be solving the questions for quiz number two. That was the in-person quiz with Dr. Rahman for CS1. And I'm just gonna go question by question. I have attached the picture of the question number one in this note. But what I want you to do is I want you to like take a picture of this question on your phone, because when I solve this, I will just say, hey, the problem is in line number six. I'll refer to the code by line number as is given in the question. So that way you have like a reference to the original question. You can ignore the my solution on the side, but because I'm gonna try to solve it with you here. Uh, so with that being said, let's just jump right into it, right? So question one essentially says that, hey, I'm giving you this piece of code. In this piece of code, I have two structs. I have a struct called movie, and then I have a struct called viewer. So think of a struct as nothing but a blueprint for a box, right? Let's just say a box or toy or something. It's just a blueprint. There is no struct is essentially gives you the blueprint, right, of a data type. That's the correct analogy right here, right? For a data type, and then in this scenario, movie has one, two, three, four, five members, and the question is asking us, hey, in this given piece of code in the main function, there is some I'm using dynamic memory allocation to like create space for this struct and the components and on or the members for inside of it. And what I want you to do is identify where I have made the mistakes, and then identify those mistakes and try to solve those mistakes, right? So let's just, with that being said, hopefully the question is like completely clear, and we're gonna jump right into the solution, right? So as you can see in line number six, what we're saying is we have a movie pointer called M equals to malloc size of a movie, right? This is completely valid. We have a struct for movie, and what we have done through this line, we have created this box, and then movie, just think of it as a blueprint, right? We have created this box with this line of code, completely fine, no issues here. But the issue lies in line number seven, right? We have created this box, that's fine. But in line number seven, what we're with the power of dereferencing, what we're doing is we're saying m arrow title is equals to inception, right? This is a problem. We can't do that. The reason why we can't do that, because as you can see, the first member is character pointer title. Since it's a pointer, that means I need to create the memory first, right? Because title is a character pointer, so it has what it can do. It can either hold the address of a character, right? So when it can hold the address of the character, that means it can also point to a array of characters, right? Because what malloc does is returns the starting address of the array. And since we know that arrays are contiguous in memory, so like arrays have like indexes like this, right? So this is like a piece of memory that is contiguous in memory, like meaning it's like just a block that is in memory, and the indexes are 0, 1, 2, 3, 4, and so forth. uh, so I know that I can assign it either a address of an array, or the starting address or starting ad well, sorry, an address of a character, or the starting address of the array itself. And then since I know it's in contiguous block, I can like access all the other indexes, right? So that makes sense, right? So what we need to do is we need to allocate space for this part. So we can just say uh, m arrow title equals to malloc string length strlen of inception, and I'm going to do plus one because we want to leave space for the null terminator, so that way we know when the string ends, right? So this is the issue and this is the solution. That's line number seven. We are not creating any space, and we're just assigning, as without creating any space, I'm just assigning it a string, right, which will create an error and our code will not even compile. That's the first issue. Second issue is in line number 11 and line number 12. Essentially we're doing the same mistake here as well. So as you can see in line number 10, okay, let me go over this first, right? So what is, it says char, character, arrow, genres, right? So how do I visualize this, right? How do I visualize this variable? A lot of people get confused. How I like to visualize this, since it's a double pointer, it can hold the uh, address of a pointer, right? I know that. So that's exactly what I'm gonna do. Since it can hold the address of a character pointer, I will just assign it the word starting address of the character pointer, and since it's an array, it's contiguous in memory, I can just like go over to all the other indexes, right? So what I'm gonna do is I'm gonna malloc it like this, right? I'm gonna malloc an array of character pointers, and since each array, like each block, each element is a character pointer, this has the ability to point to an array of characters, and then one for the null terminator, and then let's just call it C, 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 C. Does that, I'm pretty sure visualizing this like cleared a lot of doubts in people's minds, because like people have a hard time like visualizing how it will look like in memory. So that's how you like visualize it to better understand you. So what we have done in line number 10, we have created the space for this box, right? For these two boxes, but we have not created the space for this character array, and then we're just assigning it sci-fi, right? And we're assigning it thriller, which is a problem because I've created this space, that is fine, but I also need to create this space, right? So that is the problem in line number 11 and line number 12. We need to do something like m arrow genres, like dereferencing it, at the 0th position equals to malloc. It would be, sorry, malloc size of a character times string length of sci-fi plus 1. 1 again for the null terminator, and we need to do the same thing for line number 12, but we just need to replace the 0 with 1 and then sci-fi with thriller. And then also we need to like use the, sorry, we also need to use the string copy function, right? We need to do strcpy string copy, so destination, and then the source. So we can just say destination is m arrow genres at the 0th position equal catches sci-fi, which is just a string. And then we have created the space, and now we're assigning this now in this empty space I'm assigning it the value sci-fi, which is just a character array. So that's the problem. There's the same problem in line number 12, but I want you to try solving this on your own. And we have essentially in line number 16 and line number 7, oh no, line number 18, again we're doing the same mistake. In as you can see in line number 15, I'm creating the space for the viewer, which is another struct, but I'm dereferencing it, the name field, and without creating any space, I'm just assigning it the string, right? So that's a problem. I want you to solve this part, and this part on your own, so this way you have a little bit more understanding when you go to the midterm or to the FE. So those were the mistakes. And then also the last mistake is obviously we are not freeing the allocated space, right? So again, remember, when you free, you have to free from within. So you don't have to write the whole free function or like the free part, but you could have just said, like, you can have said like, hey, we are not freeing the memory, and you can write the comment like something like, hey, when you free memory, you have to free the memory from within, so that way I'm not creating any memory leaks. So hopefully that was clear and cut. If you have like problems still understanding, you can always come visit my office hours. They're on the homepage. And yeah. Okay, again, you can like pause the video. I'm now gonna be solving the part 2 of question number 1. This is that, and then I will be solving question number 2, part 1 and part 1 and part 2. So you can ignore my solution because again we're gonna solve it. So hopefully you've taken the picture. Wait, pause the video, take a photo, pause the video, take a photo. Uh, all right, so I'm pretty sure everyone has taken a picture. So question one, part two just says like, what is the correct way to allocate memory for the string thriller, right? So uh, okay, so option A is definitely not correct because again we have, as we discussed in part one, we're just assigning it a string. We need to allocate the space, right? So option A is obviously not correct. Option C looks somewhat correct, somewhat correct, but it's since genre is already declared as a dynamic uh, array, uh, we can't like rewrite the code, right? So A and C are obviously incorrect, and the possible choices I have is option B and option C. So the thing is, option D looks at first glance correct, right? Because hey, what I'm doing is I'm creating the space, right? I'm creating the space, but the problem is I am creating space using the size of operator for a string. We can't do that. For a string, we need to use the string length function, right? As we discussed in the previous part. So that is also incorrect. And now comes that option B. Now option B just says character genre equals to malloc, and malloc just essentially takes in one argument, and in this case I'm passing 9, right? And why am I passing 9? Because as we learned, the size of a character is just 1 byte, right? So what the malloc will do is it will create 9 bytes of memory in contiguous memory. So and then we can just call string copy genre, genre being the destination and the source being thriller, right? So this is like a little bit trickier, but that's the right answer. So hopefully that was pretty. Now that I've explained it to you, hopefully now you understand. The size of a character is 1 byte. Size of an int is 4 bytes, and so forth. You can look up size of a double or a float before you go to the FE. But this now that you know that, it's like pretty easy, right? Malloc just the function malloc essentially just takes in one argument, and that is how many bytes I want to allocate in contiguous memory. So that was the part two of question number one. So now let's come to question number two, which is one of my favorite algorithms, binary search. I love this algorithm. I have solved plenty of questions using this algorithm, and I think this is a very, I would say this is a top 10, not important, but like top 10 algorithms for like interviews and all that kind of good stuff, right? Uh, I love this algorithm. Anyways, so it's just a student wrote a recursive binary search function, find their target value in a sorted array. Again, for binary search to work, the array has to be sorted. However, the function sometimes return incorrect results. Your task is to one, trace the recursive calls for the given input, right? And for the first part, we're gonna assume that the binary function is correct. And the second part, what I want to do is I want to identify the mistake in the function, right? So, all right, for the first part, it's just like tracing binary function or the binary search, right? So the code is given to us. We can like refer to that code. So let's just call it BS, like binary. Oh wow, binary search, right? And we pass in the array. We pass in a left tracker, which is 0, and a right tracker, which is 5 in this case, right? 0, 1, 2, 3, 4, 5, yeah. And then we pass in a target, and target essentially represents the value that we're gonna look for in our array, right? So first call, we're gonna calculate our mid, which would be 0 plus 5 divided by 2, right? Left plus right divided by 2, and then the value would be 2, right? Because it would be like 2.3 something something, but since it's C and it's like integer division, it will we always like round the value towards the 0, so it will just become 2, right? Since it's integer division. And what it will do is, now we have this array, right? We have our array 2, 4, 6, 8, 10, 12, and this is the target that I'm looking for. So what it will do is it will go to mid. So let's write the index. So 0, 1, 2, 3, 4, and 5. Left is here, right is here. And what we'll do is now we will go to the this index, right? And we will check if this is the value that I'm looking for. That's not the case. Then I will go to the second conditional that says if otherwise if array at mid is bigger than the target that I'm looking for. That's not the case, right? 6 is not bigger than 10, right? So that else if block will not function. Hopefully you have taken the picture, but because if you have the picture on the side of the function, this would like really come in handy, right? So hopefully take the picture. I'm just gonna show it to you again. Yeah, right? So 6 is not bigger than 10, so this else if block will also not function. Now I will go to the third condition, which is just says else. So that means array at mid is smaller than my target, right? Array at mid, which is 6, is smaller than the target that I'm looking for. This checks out. So what I'll do is I'll move my left tracker all the way, so this was mid, all the way over here, right? So that's the first call. In the second call, my array should look something like 8, 10, 12, and the indexes would be 3, 4, 5. Left is here, right is here. Again, I will calculate my mid. Mid equals to 3 plus 5 divided by 2, which is 8 divided by 2, 4. My mid is here, right? Now, again, in my very first if block, I'm checking if array at mid equal to target, right? Mid is here. Now we're checking if array at mid, which is 10, is equals to my target, which is 10. Correct, right? I'm just going to return the index, return mid. So we will return 4. That's how you like trace binary search. And how many calls we made? We just made 1 call, we made 2 calls, right? Hopefully that was a little bit easier to understand. Again, if you have questions, please come visit my office hours. I can go more in depth since you'll be there in person or in online, so we can communicate better where you're having a trouble connecting the question, right? So that's the 2 calls made, and then we found the answer, and then we returned it, right? Pretty straightforward, right? Now I will solve part 2 of question number 2, which says like the given binary search function has a problem. So we're gonna identify the problem. So let's say part 2, and the problem is not in any of the else if block. The problem is in our base case, which is if left is bigger than or equal to my right, return 1. And why this is a problem? This is a problem because let's say we have this array, something like this, right? Boom, boom, boom. We have a left, we have a left here, we have a right here. Let's just call it 1, 2, 3, 4. And the target that I'm looking for is 2, right? Let's just call it T, right? Let's say for some scenario, I don't know, this is not gonna be the case, but let's just assume, right? Let's say our mid landed here, right? And we're looking for 2, right? This is not the case, right? So I'm gonna move my right to here and my left to here, right? So, sorry, let me explain it a little bit better because I think I kind of rushed through it. Okay, let's say I'm calculate my mid again, right? So indexes are 0, 1, 2, 3. We did 0 plus 3 divided by 2, and we landed at 1, right? So our mid landed at 1. Let's just assume that this is not the value I'm looking for, this is the value I'm looking for. Let's just change it. So for a better example, right? This is obviously not the value I'm looking for. I'm looking for 3, right? So we'll go to the first block that says if array at mid is smaller than the value that I'm looking for, 2 is smaller than 3, so move left to mid plus 1, which would be here, right? So that's the first call. In the second call, now our array becomes just 2, 3, and 4. Indexes are 2 and 3. Left is here, right is here, right? Again, we calculate the value. Let's assume mid lands at this position. Again, we're not looking for 4, right? So now our array just becomes 3, left and right. And the thing with this is, if the condition says if left is bigger than or equal to right, my function would just end. But we did not check the value at this position, right? We have to check the value if left and right are still equals. So that's the issue. So it should say if left is bigger than right. That should be the case. And so that's one example. Another example, a very small or a very niche example, is let's say the size of the array is 1, right? The array is of size 1 and it only has one element, 1, and the target I'm looking for is also 1. So left will be here, right would be here, because the size of the array is just 1, right? So, and this is like, let's say index number 0. So it would do 0 plus 0 divided by 2, which is just 0, right? And if my base case said if left is bigger than or equal to r, it would just go to the base case, not check the value, and just end, right? So that's another test case that we have. The if we have this condition, if L equals is bigger than R, I still want to check the values, right? So that's the issue with the code. uh, Hopefully, again, same thing. uh, try like drawing the calls, like try doing your own, like something like, let's say I'll give you an array, for example. Let's call it 3 9 11 22 0 1 2 3. Left is here, right is here, and the target that I'm giving you is 9, right? Try solving this question, like try doing the calls on your own, so when the time of midterm comes, you already have a solid understanding of binary search. Again, very important algorithm. If you're going for like a software developer job, that kind of all that kind of good stuff, you're gonna be doing, probably a good chances you're probably gonna be solving like problems on binary search, like lead code type problems, and this is a very, famous algorithm. So practice this. Again, I hope you guys take the pictures. Now I'm gonna be solving the question, part 3 of question number 2, which just says like what's the time complexity of the binary search function, and it's asking you for the worst case scenario. One trick that I would like to give you is whenever they ask you for the time complexity of a given function, you always have to tell the worst case scenario. You don't have to tell the best case or the average. We will get to this more in depth later during the semester for CS1, but time complexity essentially refers to the upper bound of the function, right? So you always have to tell the worst case scenario, right? So in binary search, it's just order of log n, because each iteration or each recursive call, I am essentially dividing the array in half, right? And then, so that, like, you're dividing the array in half, and then if you do the math for that, I'm not really the best person for this, but it essentially just boils down to like log n, right? And I just remember this because I've solved binary search questions like a good amount of times, and then it's something that just makes sense. Hey, each and every step, I'm dividing the array in half, so that just like I have like made the connection in my brain that, hey, if I'm dividing the array in half each and every step, it essentially means log n. That's how I remember it. But there is we're gonna go more in depth about how and why the binary search function is log n later as on we go in the semester. So hopefully that clears it up. Probably did not do the best job at explaining that, but that's how I have made the connection in my brain. So yeah. Now for question number 3, it just says, given a number 231 which is in base 4, convert it to base 8. So how I solve this question is pretty simple. I know that it is given to me in base 4, right? So what I'll do is, first step, I'll convert it to base 2, or I'll convert it to binary. Binary being base 2, right? Binary is just base 2. So how to convert a number to uh, base 2 is pretty simple. I'll just write the numbers one by one. So it'll be 2, 3, 1. 1 in binary is just 0 and 1, right? 3 in binary is just 1 and 1. And 2 in binary is just 0 and 1. And how to convert a number in binary? Let's say the number is 4, right? I'm gonna write the binaries table is like 2, sorry, it'd be 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 4, and that's how you get the answer, right? So it'd be like 1 2 4 16. oh sorry, 2 to the power of 3, right? So that's like the table for like how to convert the stuff into binary. And uh, and if you do the math, let's say we have the number, let's say we have the number 1, right, which is just 1 2 4 8 16. I can just write this table, and then 1 is just 0 plus 1, right? I get 1. That's 1. For 3, I'll write the table 16 8 4 2 1. 3 is just this 2, right? So that just becomes 3. So I get 3 equals to 1 1. Again, 2 is just this, so 1. So we get the values 1 0 1 1 0 1, right? This is in base 2. Again, I want to convert it to base 8. Now I know that 2 to the power of 3 equals to 8. So I'm going to use this. I'm going to use the shortcut method. I'm going to group this number into in groups of 3, and then I'll convert it, right? So it was 1 0 1 1 0 1. Again, group it in 3, right? And then I'll convert it, right? So numbers for again, I'm going to write the table up top. 1 2 4 1 2 4, right? What is 4 plus 1? 5. What is 4 plus 1? 5. You get the answer 55. Yeah, hopefully that cleared it up a little bit. Again, uh I'm not the best at like explaining like math stuff. So that's like one of the ways I have like remembered it, because the thing about this is like I've once you solve enough questions for like base conversion on all that, you kind of just you don't if you're like me who has like a tough time understanding like math concepts, but if you solve enough questions, let's say 10 to 15 questions on like base conversion, you eventually start like your brain eventually starts to like memorize the pattern, right? So that's just it's all about, if you're bad at math, just you know try try grinding out like a good 10 to 15 questions, and after that I can give you any questions and you'll be able to solve it. So hopefully that cleared it up. Again, any questions, come to my office hours, more than happy to help.